last two videos, we've looked at finding sides of a triangle and angles of a triangle using the law of sines or the law of cosines. So what happens if we're giving a side-side angle? So let's draw a triangle here, A, B, C. And A is 2, B is 6, and the measure of angle A is 30. So the first two numbers were side lengths. So I'm going to use the law of sines to solve this. If I have an acute angle, because I'm not sure how the triangle is drawn, I can actually have the possibility of two different answers. So we will always assume two answers if the angle that we find is acute. That is less than 90. So sine of B divided by 6 is equal to sine of A divided by 2. So sine of B is equal to 1.5. If you recall, for the range of sine, it's only defined between -1 and 1. But if we are insistent and do this on our calculator, we'll get an error message, which means there is no triangle. So we cannot draw a triangle with those side lengths and the angle of 30 degrees in between. Okay. Let me erase this and rework this. Okay. Find the missing parts in the triangle ABC if A is 54, B is 62, and angle A is 40. Again, let's draw a triangle. Notice I am not drawing a right triangle. Okay, so again, because 62 is opposite B, I'm going to use the law of sines. Sine of B over 62 is equal to sine of 40 over 54. And since we have two numbers, usually your angles are rounded to two places to the nearest whole number. And since this angle A is rounded to the nearest whole number, by doing the math, we get B is equal to 48 degrees. Now that is an acute angle, so what could happen? We could have a possibility of two triangles. B is 48 degrees, or B is equal to 180 minus 48. B is equal to 132 degrees. So we're going to see if both triangles could be drawn. So what we do is we use the given information. And in the first one, I'm going to assume 48 will work that. In the second triangle, we'll assume that the 132 degrees is the measure of angle B. Okay, so again, remember using the triangle sum theorem, 3 angles of a triangle add up to 180. Angle C is 92 degrees. So that's your first missing piece of information. Now we need to find side C. Oh, and also here, measure of angle B is 48. So what I'm looking for is what is side C length? So C over sine of 92 is equal to 62 over sine of 48. And doing the math, we get C is equal to 84. And our units are centimeters. So that's one triangle we can have. Now let's draw a second triangle, assuming that B is 132 degrees. That's an obtuse angle. So we will make that angle look obtuse. Let me redraw that triangle there. Okay. And we will go A, B, C. Now for these answers, okay, we're going to say angle B is equal to 132 degrees. We have that right here. And what is angle C then? Well, again, since the three angles of the triangle add up to 180, angle C is 8 degrees. So we're going to do C divided by sine of 8 is equal to 62 divided by sine of 48. So C is equal to 12 centimeters. So we found the missing side, because if you look at what your given information is, you know A and B sides, and there's the side for C, and you found your missing angles. So if B is 48 degrees, angle C is 92 degrees. However, if B is 132 degrees, we have that triangle, C is 8 degrees. Now, let's see what other type of triangles we can have. Find the missing parts of a triangle if C is equal to 35.4 degrees. Side A is 205 feet. Side B is 314 feet. Now, notice C is rounded to one decimal place, the angle. So we will round our answers to one decimal place. Okay, so let's use the law of sines. So we're going to do sine of A over 205 is equal to sine of 35.4 over 314. So we're going to solve this. So measure of angle A is equal to 22.1 degrees. Okay. Now, once again, we're assuming that there could be two triangles. You saw in the first example that we couldn't even get one triangle with the given information. Okay, actually, I thought I made a math here. We're going to do 22. If we use the information I have, it's going to be 22.2 degrees. Okay, so again, assume two triangles for me. One where measure of angle A is 22.2, or measure of angle A is 180 minus 22.2, which is 157 degrees. 157.8 to be exact degrees. So we have 22.2. C is 35.4. A is 205. C is 314. Okay, so that's given. So let's solve for angle B. So here, measure of angle B is, now let's see if we get a triangle here. We probably will. Okay, B is 122.4 degrees. Now, I'm going to tell you, class, when I do the other math on the other triangle, we can't have a second triangle. If you have an obtuse angle for any of the three angles, A, B, or C, we can only have one obtuse triangle. So B divided by sine of 122.4 is equal to 314 over sine of 35.4. So doing the math, I get 458. So B is equal to 458 feet. Okay, that's when A is 22.2. So we have this triangle here. Okay, we also need to write down what, well, angle C was given. We have that triangle. Now, let's try this second triangle here. Can we even form a second triangle? What can happen with the given information? You could have one triangle, two triangles, or no triangle formed. Okay, so noticing again that A is an obtuse angle, I will move A to be an angle with the horizontal. So we have A, B. Okay, I apologize, that is not an obtuse angle. Let's put the A here. A, B, C. So C was given at 35.4. So angle A plus angle C is equal to, I'm using the 157.8 plus 35.4. That is 193. That is greater than 180. So we do not have that second triangle there. And again, because B was an obtuse angle back here, there can only be one triangle given or drawn with an obtuse angle. Okay, let's try the law of cosines. All right, so I'm going to put C here. So I know angle A. So we're going to use the formula A squared is equal to B squared plus C squared minus 2BC cosine of A. So 54 squared is equal to 62 squared plus C squared minus 2 times 62 times C times cosine of 40. Now, I would like you to notice something. We actually have some numbers here. So I can combine these by moving the 54 squared over and subtracting. And then this here, not the C, because that's an unknown. But this times this and then times the cosine will give us a number. So here's what's going to happen. This is going to become a quadratic. So it becomes C squared. Okay, so 2 times 62 times cosine of 40. Now, here's part of our problem. We might run into a little bit of rounding errors here. So, let's see. 2 times 62 times cosine of 40 is, I get 94.9895. So C squared minus 94.9845. Let's go ahead and use this number, C. And then we'll see, is it plus or minus 62 squared minus 54 squared? That's going to be plus 928. We will do the quadratic formula. And in the quadratic formula, okay, it's a little bit tricky since I used a C. It might have been a little clearer if I'd used X. So here, A is 1. B is negative 94.9845. And in the quadratic formula, C, I know that's a C there. C, so let me call this, how about C prime, is equal to 928. So if you remember your quadratic formula is X equal negative B plus or minus square root. So there's two answers there. B squared minus 4 times A times C all over 2A. So X is equal to 94.9845 plus or minus. Let's see what that is. Let's see. 94.9845 squared minus 4 times 1 times 928. We get 5310. Let's go ahead and take a square root. And I get 72 point, there's a decimal point here. Let's go to 4 decimal places, 8701, all over 2. Okay, now I went to X, so theoretically our X is C, so let me correct that. I often use X just because of the quadratic formula. Okay, so let's see, 94.9845. Now notice these numbers are both positive, so we are going to get two triangles. So for one angle measure, actually this is length C. So for one of length C, I get C is equal to 84. Okay, or if I do the subtraction, C is equal to 22. Okay, so now we have to find angle C. Since we are using the law of cosines, to find our angle C, we will use the law of cosines. So cosine of C is equal to, if I solve for cosine of C, it's going to be A squared plus B squared minus C squared divided by 2AB. So let's see. So that's going to be, okay, so in the math, we're going to get 54 squared plus 62 squared minus the 84 we just found. And I get cosine of C is equal to negative 296 divided by 2 times A, 54, times B, which is 62. 6,696. So angle C is equal to 47 degrees. And then A is equal to 180 minus 40 minus 47 is 93 degrees. Oh, not A, I apologize. B. We already had angle A. So B is equal to, let me double check that cosine of C. I think I may have made a map. Okay. All right, I am sorry I accidentally hit a decimal here when I was checking. Let me do cosine inverse of negative 296 divided by 6696 is 93 degrees. Okay. I was looking at my answer key and I had these switched. So this should be 93 degrees. And then when you do 180 minus 93 minus 40, angle B is 47 degrees. Okay. So those are the two angles and the side for one of your triangles. Now, C is 22. Cosine of C is equal to, when you plug it in, 6639 divided by 6696. So if you do second cosine, and you can go ahead and type in 6639 divided by 6696, and I get 7.8. So I'm going to get angle C is 7 degrees. So 180 minus the sum, which is 47, gives us angle B is 133 degrees. So what information did we find here? Okay, so we found when the length of C is 84 centimeters, do not forget your units. Angle C is 93 degrees, angle B is 47 degrees. When the length of C is 22 centimeters, angle C is 7 degrees and angle B is 133 degrees. So you can see, given an acute triangle or an obtuse triangle, not a right triangle, using the law of sines or the law of cosines, we're able to find the missing parts, or we're able to find a certain angle or side.